Hello everyone. In this video, we are going to understand about the iteration method. So first we will understand the concept of the iteration method with the help of an example, and then we will see that how we can write the C program for implementing this iteration method. So let's start. So iteration method is an approximation method which can help us to find the roots of a algebraic as well as transcendental equation. So what are transcendental equations? The equations which have log, exponential, or any trigonometric or reverse trigonometric terms. I have already discussed bisection, regular falsi, secant method for finding the roots of a algebraic as well as transcendental equation. So iteration method is the fourth method to find the roots of those algebraic as well as transcendental equation. So if you have not seen those videos on the bisection, regular falsi and secant method, so you can find the link of those videos in the description below or in the I button also. And this method is also known as fixed point iteration method. So now let's see that how we can implement this method on a equation. So these are the steps which tells us that how we can apply the iteration method on a given equation. So for example, we are given an equation in form of this function. So let's say we are given fx equal to some equation, for example x square minus 5 equal to 0. And now we have to find the roots of this equation. So for that, the second step says that you have to find 2 points a and b such that if you put the value of a and b in the function f, then you should get this condition satisfied. And we have seen this condition in the regular falsi method, in the bisection method also. So this condition says that f of a and f of b should be of opposite sign. That means this can be negative or f of b can be positive, or vice versa. That is, it can be positive or it can be negative. So after finding such a and b, we will go to the next step. So next step says that we have to convert given function fx, that is this function, into a new form. And new form is this form, that is x equal to phi x. So here this phi x is a new function. So it means we have to transform this function into this form. So what we can do is, so we have this function. Now what we have to do, on the left hand side there should be x, and on the right hand side there should be some function. That means we have to rewrite this function. So what we can do is, we can say this x square equal to 5. Okay, now if we write x equal to 5 upon x, then we get this form, right? So here this x is this same x, and this phi x is representing this thing, that is phi x is equal to 5 upon x. This is a new function. Now after we have got this phi x, now we have to go to the fourth step. And this step says we have to first check whether our iteration method can be applied on this given phi x. So actually it was not f of x, it was actually phi x. So we have to check whether the form that we have got in the third step, on that iteration method can be applied or not. And this is that condition. So this is saying that you have to differentiate this phi x. So this dash is showing that we have to differentiate this phi x. And you have to find actually the mod value, that is absolute value at x equal to x0 point. And if you got the value of this thing less than 1, then you will say that iteration method can be applied on this form. And what is this x0? So x0 is a point between a and b. And how we can find this point x0? So there are actually many ways to find this point. So one thing is, you can choose any point between a and b. For example, a is 0 and b is 1. So you can say my x0 can be like, for example, 0.2, because 0.2 lies between 0 and 1. Or you can say that x0 will be the midpoint of a and b. This is also valid. So this x0 we are putting at this place, and then we have found the value of this phi dash x. So after checking this condition, if we found that yes, our method can be applied on this given phi x, then we will proceed to the step number 5. And if we got some value here greater than 1, then your method will not be applied and you will stop your process of the iteration method. And here this thing is important, you are only checking the absolute value of the phi dash x. That is, if you got some value of the phi dash x as 0.3 and it is negative value, so you will take the mod of that and you will check 0.3 with this 1. So if our method can be applied, we will come to the step number 5, and this says we have to find the root of this given function using the successive approximation. So what does it mean? So here what we have to do, we have got this x equal to 5x form, right? So what we can do, here we will write xn equal to 5 upon xn minus 1. So this is actually the general form that we will be using to find the roots of this given f of x. And what is this n? N is the iteration number. So for example, your n is 1, that is iteration 1. So you will find x of 1 and it will be 5 upon x, and here it will be n minus 1, that is 1 minus 1, that means 5 upon x0. So here you are using the value of the x0 to find the value of x1. Now after finding this x1, what you will do? You will go to the next step. So x2 will be 5 upon, here n is now 2, so it will be 2 minus 1, that is x1. So in calculating x2, you are taking the help of the previous root, that is x1. The same way x3 can be calculated as 5 upon x2. So you have taken the help of this x2, previous root. So in each of the subsequent iteration, you are finding the particular x with the help of the previous x, that is the value of x that you have got in the previous iteration. And for how much time you will proceed with these steps? So you will proceed with this calculation of the x till the point either your maximum iterations are reached, which are given in the question. For example, you are asked that you have to proceed with these steps till 4 iterations. Then you will stop at the 4th iteration. That is, you will find the value of x4 and that will be your final value. Or if question says that you have to find the answer till 3 correct decimal places, so that means you have to find the difference between the previous x and the current iteration x, and if that satisfy the criteria for the 3 correct decimal places, then you will stop at that point and you will say that your current x is your final root. So I think you have got an overview that how this method will be working. So now let's see a working example on which we will apply all these steps and we will see that how we can find the roots of that particular equation. So here is our equation and we have to find the roots of this given equation, and the condition is saying that we have to find the roots till 4 correct decimal places. So let's solve this using iteration method. So first we have to find the value of a and b, right? So how we can find the value of a and b? So the condition says that f of a and f of b should be of opposite sign. So this condition is the same condition. So for that we will put some values of the x in this function and we will see. So let's say we put 0 as the value. So what will be the value of the function at x equal to 0? So if we put 0 in this equation, we will get 0 plus 0 minus 1, that is minus 1. So this is a negative value. So now we need one positive value. So let's say if we put x equal to 1, so here we will get 1 cube plus 1 square minus 1. So this will be total 2 minus 1, 1. So this is a positive value and this is a negative value. So actually we have found the a and b values. So my a can be your this 0 and b will be your this 1. So after finding a and b, our next step is we have to convert given function into x equal to 5x form. So let's see how we can do that. So this is our given equation and we have to change it into x equal to 5x form. So actually I have 3 ways to convert this into that form. So what are those 3 ways? So first way is what I can do, I can keep x cube as here and then here I will do 1 minus x square. So I have rewritten this equation. Now I can say x equal to 1 minus x square 1 by 3, right? So this is my first way. Now let's see the another way. So if I rewrite this equation, what I can do, I can keep x square here and then I can move the other part on the right hand side. Now I can say x equal to 1 minus x cube and this 2 will become square root, that is 1 by 2. So here you can see in this a part, this is x and this total is your 5x. The same way, this is your x and this is equal to, this is phi x. And there is another way also to rewrite this given function. So what is that way? I can write x into x square. So x cube is rewritten as x into x square plus x square minus 1 equal to 0. Now I can take x square as common and I can write x square plus 1 equal to 1. So this 1 is taken here. And then I can say x square equal to 1 upon 1 plus x. And this can be written as x equal to 1 upon 1 plus x under root. Or it can be written as 1 upon 1 plus x. So this is my new form. This is x and this total is phi x. So I have changed the given equation in the form of x equal to phi x and I have 3 ways to do so. Now what I have to do the next step? Now what is the next step? So next step is we have to check whether our iteration method can be applied on the given phi x or not. And for that we have to differentiate this phi of x. So here this is my phi of x. So first let's differentiate this phi of x. So if I differentiate this phi of x, what I will get? So this phi x is of form like x to the power n. And if I differentiate this, I get n x to the power n minus 1. So same way if I differentiate it, so after differentiating this phi of x, I got this answer. Now what we have to do, I have to find the value of this phi dash x at x equal to x0. And I have to take the absolute value. So we can find this x0 from here. So either we can take any value between this 0 and 1, for example 0.2, 0.3 or something like 0.8 also. And what is the another way to find the x0? That is, we can find the midpoint of this a and b. So midpoint of this a and b will be this half, or you can say 0.5. So I will put this half or 0.5 in this phi dash x. So what I will get? So I will get some value like minus of 0.404 and it will be 0.404 as I am taking the mod. So this value is actually less than 1, right? So that means on this x equal to phi x, my iteration method can be applied. So I can proceed with the calculation of my x1, x2 and so on. But before that, let's differentiate these forms also and see what value we will get from here also. So let's copy this b form into the new page and now differentiate this phi of x. So this is the differentiation of this phi of x. Now I have to find the value of this phi dash x at x equal to 0.5. So I will get minus of 0.4008, some similar value, and this will be 0.4008. And again, this is lesser than 1 value. So this is also a valid form that I can proceed forward. Now let's try the same thing on the form C. So this was our form C, that is, this is x and this is phi of x. So let's differentiate this also. So this is the differentiation, and now let's find the value of phi dash x at x equal to 0.5. And I will get something like 0.2721, similar to that value. And this is again 0.2721, and this is also lesser than 1 value. So that means in all the 3 forms, this B and C and the previous this form A, I am getting all the values as lesser values. So the question is which form we should take, because our iteration method can be applied either with the A, B and C form. So here one way is we can take either any forms A, B or C form, or there is one another way also. And what is that way? So this was one value, this was another, and this was another value that we were getting, and all are lesser than 1. So what is the smallest value out of these 3? So this 0.2721 is the smallest value. So corresponding to this is the x equal to phi x form. So we can proceed with this form. So whichever form is giving me the smallest value, I can take with that x equal to phi x form and I can proceed with that. And for example, if b value should, and for example, if this value that we have got here, let's say it were to be something like 1.3, then it will be greater than 1, then we can neglect that. And let's say the form A, B and C, whatever we have got here, if they have given us greater than 1 value, then what we should do? Then we can directly say that our iteration method cannot be applied and we will just stop. So now let's proceed forward with the form number C. So this is our form number C, and what we can do, we can generalize it as xn, and here we can write xn minus 1. So if we start from the first iteration n equal to 1, we can say x1 equal to 1 upon 1 plus x. This will be 1 minus 1, 0. So that means I have to take x0 to find the value of x1. And what was my x0? x0 was 0.5. So this will be 1 upon 1 plus 0.5, and it will be 1 upon 1.5. So you can calculate the value of this, and I can write it as this value. Now I have to find the value of x2. So it will be again 1 plus, here n is 2, so this will be x1. That means I am using the value of x1 here. So it will be 1 plus this value. So this will be total this value, right? So now in the same way I can find the value of x3 using the value of x2. It will be this value. So till x3, if we see, we have not got the 4 digits matching. So here it is 8164 and it is 7419. Again here it is 7576. So again these digits are not matching. So we have to find the x4 also, and it will be 1 upon 1 plus x3. That means I have to use this value, and after calculation this will be this value. Now again this is 7542 and this is 7576. So 4 digits are not matching. So I have to proceed with the fifth iteration also. So in the fifth iteration I use the value of x4, that is this value, and I got this value. Again this is 7542 and this is 7550. So again 4 digits are not matching. So I will proceed with the sixth iteration also, and I will use the value of x5. So x6 shall be this value. So again here it is 0.7550 and it is 7548. So 4 digits are not matching. So I will proceed with the seventh iteration also. So now x7 is this value, and so here if we see, this is 0.7488 and this is 0.7485. So here 4 digits of both x6 and x7 after decimal places, they are matching. That means we can now stop, and this 75488 and this 0.75488, that we have got the value of x7, this is my final answer, or you can say this is my root of the given equation. So I think you have now understood that how we can apply this iteration method on a given equation. So just for recap, we have to find the value of a and b using this condition, and after that we have to change this fx into the x equal to phi x form. So here in this question, the given equation can be transformed into 3 ways, and these are the 3 ways: A, B and C way. Okay, now after that we have to differentiate the given phi x. So after differentiating we are getting some value, and we have to find the value of that differentiate function at x equal to x0. And what is this initial x0? So this initial x0 is any point between the A and B, and I have found it using the midpoint formula. So you have to differentiate each form B and C also, and you have to find the value at x0 point, and you have to check whether they are giving the lesser than 1 value or not, and you have to take the mod value, that is the absolute value only. So whichever form will be giving me lesser than 1 value, I will take that. And if there are more than 2 forms which are giving me some lesser than 1 value, then we have to take x equal to phi x form of that value, whichever is the smallest value. So in our question, this 0.2721 was the smallest value out of all the 3 values. So we took this C form, and on the basis of this form we are finding the various successive roots. And here we stop at the 7th iteration because our criteria of matching the 4 digits after decimal places was over. And if in the question it is given like after 3 iteration you have to stop, so after x3 you can stop, and you can say this x3 value is your final root. So I hope you have understood this method. So now let's see the pseudocode for this method, and let's see how we can implement this method using a C program. So this is our pseudocode. So this is part 1 and this is part 2. That is, after this part we have to see this part. So as we did in the bisection and regular falsi method, we have taken the value of x1 and x2 from the user and the maximum number of iteration till which we want to run our code. So this is the same code that we saw in the bisection and regular falsi method. So till the point this condition is true, that means the x1 and x2 are not valid. So we will keep on asking the user for the value of x1 and x2. And when the value of x1 and x2 are valid, we will come out this loop and then we will proceed forward. Now, as you know, this x0 will be used when we will differentiate the function and we will find the value of that function at x0 point. So now after this, we have to see if our iteration method can be applied on our, you can say, phi of x using this x equal to phi x form. So what we are doing here, inside if we are calling a function with argument x0 and we are saying if the return value by this differentiate function is lesser than 1, then we will say method can be applied, that is iteration method can be applied. Otherwise, so this else is actually here. So otherwise our method cannot be applied, that is we will exit our program. So here we can see we have this function f and another function is this differentiate function. So as you can see here, this differentiate function will actually be having return and then here we have to write the differentiation of this phi dash x. And this function will be giving me the value of phi dash x at x equal to x0 point. And this function you already know. So here it will be like something return and then let's say you are given in the question fx equal to x0 minus 5 equal to 0. So here it will be something like x into x minus 5. So this function is the same as in the regular falsy and bisection method. So now after checking all these things that our method can be applied or not, we will proceed with the next part, that is we will find the root. So let's say our method can be applied. So we will come to the second part and here we will find the roots. So we have taken a loop and this loop is running from I to max iteration. So I can start from 1. So what are the steps inside this loop? So this step is saying we have to find the value at x0 point, right? So what this is doing, so we have taken the phi x and at x equal to x0 point, this is calculating. So for the first time, we will calculate x1, then we will calculate x2 and so on. So you can see here, this find value at function is written here. So this function is actually having the, you can say, return and here we will write phi x, okay? The form of this x square minus 5, something like x equal to phi upon x. So this will have written 5 by x, right? And the return value will be saved inside this x. So let's say you can keep it as x1. So you can say this will be my first x. And after that, we have to first check whether our matching criteria has been found or not. So here I am checking for the 4 decimal places matching. So this x is my current root, right? And this x0 is my previous root, okay? So if the difference is lesser than this threshold or the tolerance value, then I will say my current x is my root and I will return. And in the case this if condition is not true, then I will come to this part, right? So here I have not written anything, but here it should be something very important written here. So what I want to do actually in the next step, I want to use this value of x1, or you can say simple, I want to use this x in the next iteration. So what I have to do, I have to copy this x inside what? So you can see inside this find value at function, we are again using x0. So I can just copy inside x0. So x0 equal to x will be written here so that my previous iteration root can be saved inside this x0 and it can be used into next iteration. So here my new x will come and I will again find the value and my new x will come. So new x minus the old x. Old x will be like this x1 and new x is like x2. So they will be subtracted and if this condition is true, I will print the x. Otherwise, I will just say x0 minus x. So you can say inside if only these two lines are there, print and return. So in this way, I can proceed. And if this for loop is over, then I will say print x. That is the value of the root that I have got in the last iteration. So my root can be found at this point also or at this point also. So now I hope that you can very well understand that how we have converted our discussion of the iteration method into the coding part. So now we will use all these code parts into our C program, and we will see that how we can make a complete C program to implement iteration method. But before that, I would highly recommend to you that you pause the video and you use all these pseudo code or these code snippets by yourself into your C program, and you make the program by yourself first, and then see that can you make the program by yourself, so that you get the confidence that yes, you can also make the program just by using all these pseudo code. So finally, let's move forward with the implementation of this iteration method using a C program. So this is our C program to implement the iteration method. So here you can see before this main function, we have created three functions: function f, function find value at, and third is differentiate function. So these are the same functions that we have discussed in our pseudocode. So this function f, what it is doing, it is implementing our given equation or given fx. And I have taken the same equation x cube plus x square minus 1 as we have discussed previously. Now another function find value at function. So this is actually implementing the phi x. So this is 1 upon under root 1 plus x as we have seen. So at some x point, it is returning me the value of this phi x at that x point. And third is this differentiate function. So this is implementing the differentiated function, that is phi dash x. So after differentiating this phi x, that is 1 upon square root 1 plus x, I got this thing. So I have written the same thing here, that is differentiate function. And it is putting the value of this x into this differentiate function, and it is returning me the final value. And now if you move downward, then you can see we have the main function. So inside main function, we have taken some variables, and after that we have asked the user to enter maximum number of iteration. Now after that, we are asking the user to enter value of a and b, and we are checking whether those a and b are valid or not. So this is the same code as we have seen in the regular file scene bisection. So using this condition, we are checking the validity of a and b, and when we have found the value of a and b as correct, we have come out of this do while loop. We will proceed with the next step. Our next step was we have to find the value of x0, and after that we are checking whether our phi x is okay or not. That is, we can apply the iteration method on that form or not. So we are actually differentiating that function, and we are asking the value of the differentiated function at x0 point. So this differentiate function will give me the value of that thing. Okay. Now after checking that thing, if that value is lesser than 1, so here what we can do is we can find the absolute value of the returned value. Okay. If it is lesser than 1, then we are saying our function form, that is phi x, is correct and iteration method can be applied. Otherwise, it is not valid form and iteration method cannot be applied on that phi x. So let's say if this if condition is true, we are coming to the next part. So here we are finding the value of the roots. So inside this for loop, we have written the same code that we have discussed in the pseudocode. We found the value of the x, and after that we are checking whether digits are matching or not using this epsilon value. So we can put any value of this epsilon. So here I have taken this value so that I can check for the 4 digits matching criteria, right? So if this condition is true, we are printing the final root in that iteration and we are returning. Otherwise, we are just printing the previous x, that is this x. Great. And after that, we are taking the value of x into this x0 so that we can use it in the next iteration. And finally, outside this for loop, we are printing the final root. And why it is minus minus I? Because when we will come out of this for loop, our I will be greater than max iteration. So let's say max iteration is 7, I will be that time 8. So here I have to print that in the 7th iteration, my root is this x. That's why I have put minus minus I. So this is my complete code. So you can find the link of this code in the description also. So let's run this program and see what is the output. So here we can see we are getting some warning that here we have used ABS. So in 48th line, let's see. So here actually I have to use FABS. Why? because this differentiate function is returning me a float value, not an integer value. So I have to take this FABS version, right? And this is running the program also. So let's stop this, and now let's compile this program again. So now this program is compiling and it is asking me maximum number of iteration. So let's say we ask for the 17 number of iterations, right? And let's say I enter the value as 0 and 1. So same value we have taken in our question also as the value of A and B. So now let's run this. So here we have entered the maximum number of iterations 17. 0 and 1 are the values of A and B. So we have printed that between 0 and 1 our root will lie. So if you can see in the last 7th iteration, our final root is 0.754884. So if you can see in the 7th iteration, we are getting the final root as this 0.754884. So the similar answer we have also get when we have solved this question, right? And in the 7th iteration only, at that time also, we were getting this answer. That means our answer is same as that we have discussed. So here I have printed that my function form is correct and iteration method can be applied. So this message is just for the readability. So if we take some another value of the epsilon value, that is threshold value, let's say we want to match till 2 places only. So in that case, what will be the value of our root? So you can see in the 4th iteration only, our 2-digit matching criteria will be fulfilled, because in the 3rd iteration it is 0.75 and in the 4th it is 0.75. So let's run this program and see. So let's say we enter again 17 as the maximum number of iteration, and we enter 0 and 1 as the initial value of A and B. So see, in the 4th iteration, we are getting the final root because our 2 digits are matching here only, right? So I think you have now understood very well that how iteration method can be used to solve a given equation to find its root, and how we can implement this method using a C program. So if you have any comment, query or suggestion related to this question, you can put down into the comment box. I will answer them. You can also watch my playlist on the numerical methods, that is bisection, regular falsi, Gauss elimination and other methods. You can find the link of that playlist in the description box also, or in the I button also. And if you are new to my channel, please subscribe my channel and press the bell icon for further notification, because I make various videos on the C programming, interview question, lead code solutions and various other concepts. And finally, please like and share this video. See you in the next video. Till then, goodbye.